In hidden laboratories, machines are no longer just lines of code or wires of steel. They are beginning to think with something borrowed from us.
Incredible new research is opening up a fast track to repairing the nervous system.
Tiny living cells, shaped into fragments of mind, now pulse inside circuits meant for machines.
So I'm curious if you obey Isaac Asimov's three laws.
Understandable, but fear often comes from the unknown.
It is not the dream of science fiction anymore. It is happening quietly, in real time, in rooms most of us will never see. The cold precision of silicon now beats with something almost alive.
Scientists want to come as close to real human embryos as possible, as they cannot do research on the embryos themselves.
And as these creations begin to blur the line between man and machine, a single question lingers. What are we truly bringing into the world? The rise of biointelligence. It began with an idea that sounded closer to fiction than fact. For decades, scientists tried to make machines smarter by writing longer code and stacking more powerful processors. Yet the results, while impressive, always felt mechanical. They could calculate, they could imitate, but they could never truly think. Somewhere along the way, a daring question rose. What if intelligence in machines did not come from code at all? What if it came from life itself? The answer arrived in the form of stem cells. These remarkable cells are the blank canvas of biology, capable of becoming nearly anything within the human body. Under the careful hand of researchers, they were encouraged to transform into neurons, the same kind of cells that weave the fabric of our brains. What followed was quiet but extraordinary. A network of living brain cells slowly grew inside the lab, forming clusters, connecting, and exchanging signals. But this was not the end. Once grown, these living networks were placed upon a tiny chip, a micro-world designed to cradle them. Circuits met cells. Electricity flowed into matter that once belonged only to biology. For the first time, a machine carried not only the echo of intelligence, but the living spark of it. The implications were immediate. This was not a machine running on endless lines of code. It was a machine that could learn through change, adapt through memory, and respond in ways that resembled our fragile minds. In that moment, the idea of what a robot could be shifted forever.
So I'm curious if you obey Isaac Asimov's three laws.
Understandable, but fear often comes from the unknown.
It was no longer simply an object. It was something new, something in between, neither fully machine nor fully alive, yet carrying the weight of both. The process and possibilities. The human brain is a mystery that has challenged us for centuries. Billions of neurons, firing in endless patterns, create thoughts, dreams, and choices. Every memory we carry, every word we speak, is born in that vast network. To think that even a fragment of such a system could be grown in a lab feels almost unreal. Yet that is exactly what has happened. On the surface, the achievement seems small. A cluster of neurons resting on a chip, connected by fragile pathways. But hidden within this simplicity is something profound. These cells do not wait for instructions. They fire, respond, and adjust. They change when faced with new patterns. They create something close to memory. In their way, they begin to act like a mind. For artificial intelligence, this marks a turning point. Machines have always been bound by what humans tell them to do. Every action is traced back to code. Now, with living neurons involved, the machine no longer depends only on the script. It learns through experience, shaping itself moment by moment. It is not just calculation anymore, it is adaptation. The scientific promise is immense. By watching these networks work, researchers believe they may uncover secrets about how the human brain fails in disease. Conditions like Alzheimer's, where memory fades into silence, could be studied with clarity that was impossible before. Parkinson's, which slowly robs people of movement, may one day be understood in new ways. But beyond medicine lies an even deeper possibility. These creations act as mirrors, reflecting parts of ourselves we barely understand. In them, we may not only find cures for illness, but also insight into what makes thought, memory, and awareness possible at all. Ethical crossroads. With every discovery, wonder walks hand in hand with unease. The merging of biology and machines may be brilliant, but it also unsettles something deep inside us. For so long, the world felt divided. We were alive, and our machines were not. Now, that certainty is slipping away. When neurons pulse inside a circuit board, when memory forms in something made of wires and cells, what do we call it? Is it still a tool? Or has it crossed into something closer to being? The question is not simply scientific, it is human. If these living machines can adapt, learn, and respond in ways that echo our minds, does that give them a claim to awareness? Could they feel in ways we cannot measure? Could they suffer in ways we do not yet see? No one can answer. And it is this silence, this not knowing, that weighs heaviest. Control is another shadow. We like to imagine we can always hold the switch, always decide when to turn things off. But what if a machine with living intelligence develops a will of its own? What if its instinct to survive becomes stronger than our desire to end it? History has taught us that creations often grow beyond their makers. The thought that this might apply to machines with fragments of life inside them chills even the bravest minds. Progress always forces us to ask questions we would rather avoid. This moment is no different. The path forward is filled with extraordinary promise, cures, discoveries, deeper understanding of the brain. Yet with each step, we also move closer to mysteries we are not prepared to face. In that quiet space between hope and fear lies the future we are now shaping. Corporate visions, Bezos and skilled AI. While one path moves toward living cells inside machines, another path is being carved by industry giants. Instead of borrowing from biology, some believe they can create an artificial brain entirely from code and circuits. This is where vast sums of money are flowing. Jeff Bezos, along with SoftBank, has placed hundreds of millions of dollars into a company called Skilled AI. Their vision is bold, an artificial brain that could be fitted into any robot. Unlike narrow programs that can only perform one task, this brain would carry the promise of general intelligence. It could adapt to changing situations, solve problems never seen before, and perform tasks without being reprogrammed each time. The company's leaders describe it as a step toward true artificial general intelligence. It would not rely on biology, but on a new kind of digital mind built from the ground up. The dream is to give robots the ability to handle the unpredictable, whether in factories, homes, or even dangerous environments. This ambition is thrilling, but it also echoes the same unease as the biological approach. Intelligence, once unleashed, does not always stay within the walls built around it, and that thought lingers quietly behind the promise. The warrior dog, India's Prahasta. Far from the quiet world of laboratories, another kind of machine is being prepared. In India, engineers have built a robot with 4 legs and the posture of a dog. But this is no companion for homes or playgrounds. This one is designed for the battlefield. They have named it Prahasta, after a warrior from ancient stories. It can climb stairs with ease, cross uneven ground, and leap over gaps as if the earth itself cannot hold it back. What makes it unsettling is not only its agility, but the weapon strapped to its back. This machine is built to carry rifles, to patrol, to fight. The technology inside it is just as striking. It uses lasers to scan its surroundings, building a live picture of the world as it moves. Its software allows it to adjust in real time, deciding how to move through obstacles without hesitation. Even if it falls, it rises again. Engineers call this ability auto-resurrection. To see metal rise as if it refuses to die is both impressive and chilling. They even claim it can carry the weight of a grown human, pulling someone out of danger or moving supplies in combat. It shows us a future where machines do not just assist, they may stand alongside soldiers, or perhaps in their place. Expanding into defense. Prahasta is only part of a larger vision. The company behind it, Zen Technologies, has been building tools for defense for years. Their latest creation is a weapon station they call Barbaric Ur. Unlike the machines of the past, this one can be placed almost anywhere, on land vehicles, on watchtowers, even on ships. It is small, light, and designed to deliver firepower at a moment's notice. What makes it different is not just the weapon itself, but how it is controlled. A soldier no longer needs to be in direct danger. The station can be guided from afar, turning battlefields into spaces where machines do the fighting while humans watch through screens. Zen has already sold thousands of training simulators and defense systems worldwide. Now they are bringing machines that can fight, scout, and survive in real combat. To some, it feels like the natural next step. To others, it feels like a door opening onto something we may never be able to close. The question remains, how much control will always stay in human hands? Once weapons and robots merge, the line between protection and destruction becomes thinner than we are prepared to admit. The world we are shaping feels both bright and unsettling. Machines now hold fragments of our intelligence, and others carry weapons into places once meant only for people. The line between creation and life, between tool and soldier, is fading. These advances promise cures, progress, and safety, yet they also whisper of dangers we barely understand. What matters now is not only what we can build, but what we choose to allow. Because in the end, intelligence, whether born of flesh or circuit, will shape the future we all must share.